Okay, moving on to section 9.2, part 2 for hyperbolas. Now we're going to be working with hyperbolas that are not centered at 0, 0. So here is a table of the changes that will be made. So horizontal, again, opens left and right. So horizontal hyperbolas, they open left and right. You can see that the x term comes first. So they're opening to the left and right, and the transverse axis is going to be parallel to the x-axis. And then on our vertices are going to be hk, but we're going to add and subtract this a value from the x. So it's going to be whatever term comes first, that is going to be the term that changes for your vertices and your foci. So in this one, horizontal, the x's come first. The x's are the ones that change values for the vertices and for the foci. The k value will stay constant. Okay. Then for the foci, again, I prefer to remember this as a squared plus b squared equals c squared. Okay, so c is always your longest distance here with hyperbolas, because that foci is on farther away from the center than the vertices are. So this is your a value here from the center to the vertice. C is the center to the foci, and then b is going to be from the center to the outside box. This is what we call our construction box or our construction rectangle. This helps us to construct that hyperbola, okay, or a guide box, whatever you want to call it. Main thing about your asymptotes, we don't want to make asymptotes difficult, okay? So it's going to be y minus k. Also notice the x minus h over here. That's exactly the same thing as that equation is right here. So if you have given the equation, you have half of your asymptote already, equation. Just do the y minus k equals plus or minus the value that's underneath the y. So in this case, it's b over a, and then the x minus h. So don't worry too much about that asymptote. That should be really easy to get. That shouldn't take a lot of math to figure out what your asymptotes are. Okay, and then there's your construction rectangle vertices as well. Okay, vertically, if you have a hyperbola that opens up and down, what we call a vertical hyperbola. Now our y term comes first. It's our y values that change for our vertices and our foci. And again, I prefer the a squared plus b squared equals c squared for your equation. And then again, for your asymptotes, there's that y minus k again, that x minus h. Pull those directly from your equation if you're given the equation. And then the plus or minus a over b. Again, just the value that's underneath the y term. So in this case, since it's vertical, the y term is first, and so a is under the y term, and b is under the x term. So this time it's a over b. Okay, let's look at some examples. Okay, example number 1. So notice we're back to centered at 0, 0. So we're just going to do a couple quick review questions. So this one is centered at 0, 0. It is also a vertical asymptote. So the transverse axis is the y-axis. And so it's going to be in the format of y squared over a squared minus x squared over b squared equals 1. So now we need to figure out what a is. A is going to be the distance from the center to the vertice. And so that's going to be 4 squared. So y squared over 4 squared minus x squared over now b squared. So we have to figure out what this construction rectangle is. So from the construction rectangle, we go from the vertice over to where we hit the asymptote, make a point there, and go straight down till we hit that asymptote again. Make another point across. So just box in that those asymptotes and the vertices like that. Now we can see that our b value is 1. So 1 squared equals 1. You can enter it like that from my open math. They're good with that. Or you can do y squared over 16 minus x squared over 1 equals 1. And then for example number 2, we've got the same thing, only this time it is going to be a horizontal asymptote. That is not what I wanted. There we go. And so for our horizontal asymptote, let's go ahead and put in that construction rectangle right now. So mark our vertices, go straight up and down till we hit our asymptotes. Go ahead and box that in. Make a good guide rectangle or construction rectangle that will help us to figure out all this information. Okay, center is 0, 0 again. It is a horizontal, and so it's our x values that are changing between the center and the vertices, center and vertices. So we're going to have x squared over a squared minus y squared over b squared equals 1. So we'll have x squared over a. A in this case is this distance right here. So a distance of 4 squared minus y squared over, that is 3. So the distance from the center up to that guide rectangle is 3 squared. You can enter it like that, or you can enter x squared over 16 minus y squared over 9 equals 1. Okay, let's start looking at some that are not centered at 0, 0. Okay, example number 3. We've got find the center, vertices, and asymptotes of y plus 4 squared over 49 minus x minus 6 squared over 64 equals 1. So first thing, let's pull out that center. Always remember to look for the x first. Don't just do, negative 4 and 6, because it's our y terms that are coming first this time. So make sure you know which one is the x terms. So 6, negative 4 is our center. List the coordinates of the vertices. Well, in this case, this is a vertical hyperbola. Vertical hyperbola. So it is going to open up and down. Also, since the y comes first, it's going to be the y values of the center that change to form the vertices. We're going to use the a value that comes underneath y to change that center to the vertices. So my center is going to change. So we have 6, negative 4 is the center. And then I'm going to add and subtract 7, which is a, to get my 2 vertices. So now I can see my vertices are negative 4 plus 7, which is 3. And then the other point is going to be negative 4 minus 7, which is negative 11. Okay, so those are our vertices. Then write the equation of the asymptote with positive slope. So remember how we talked about half of our equation. We can pick it out all of the equation of the asymptotes right out of here. So we've got y plus 4 is equal to, now we're going to take the value underneath y first, because it's always y's over the x's when we find our slope. So it's going to be 7 over 8x minus 6. Okay, now they want us to have our equation solved for y, so we're not quite done yet, but that is a really easy way to get your asymptotes. So to solve for y, all we needed to do is subtract 4 from both sides. We don't even have to simplify or clear out those parentheses. So just enter your answer just like that, and my open math is good with that answer. Okay, and that's all we need to do for example 3. Okay, example 4. Write the equation of the hyperbola that has a center at 5, negative 1, a focus at negative 1, negative 1, and a vertex at 0, negative 1. So the first thing I want you to notice is the values that they're giving us, the center, the focus, and the vertex all lie on that transverse axis. So what we want to do is we want to look at these points very carefully. What point is staying the same and which point is changing? Well, in this case, the y value is always staying the same. The x value is always changing. The value that is always changing is the one that is going to come first. So if that x value is what's changing, that means that, I know it's not centered at 0, 0, but just for a rough estimate, that means that our hyperbola is opening left to right. And so that means we have the format of x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, we also know the center is at 5, negative 1, so we can go ahead and plug that in for h and k. We also need to know what the value a is and what c is. So the distance between the center and the vertex is going to give us a. So the y values are staying the same, so we don't need to worry about those y values. The x values go from the point 5, where x equals 5, to where x equals 0. So that means a is equal to 5. B, we do not know, and they have not given us any information to find b yet. C, the y's are the same from the center to focus, but the x's change, so it's the x's that we want to look at. So 5 minus negative 1 is where we're going to get c from. So 5 minus negative 1 is equal to 6. So c equals 6. Now we can go ahead and use that equation, a squared plus b squared equals c squared. And a squared is 25, b squared we do not know yet, and c squared is 36. So subtract 25 from both sides, and we get b squared equals 11. So now we're ready to write our equation. X minus h, which is 5, squared, over a squared, which is going to be 25, minus y minus k, which is negative 1, so let's make that y plus 1 instead of y minus a negative 1, over 11. So notice that b squared is 11, so I'm not going to do 11 squared. 11 is already b squared, so I don't need to square that. And then that's going to be equal to 1. And that's all we need to do for example number 4. All right, example number 5. First thing that I notice here is our center. Our center is going to be at negative 3, and then 3. Make sure you look at the x for your x value, and your y for your y value. And then also I notice that my y comes first. So that must mean that my equation, my hyperbola, is going to open up and down. So a is going to be 3. B is going to be 2. So let's go ahead and put that center on there. Negative 3, 3. We're going to be opening up and down, so we're going to go up 3 units and down 3 units. Okay, we're going to make our construction box first, rectangle, so we're going to go left and right 2, because B is 2. So let's go ahead and put that in. This is our construction box. Now I'm going to put my asymptotes in next. So I'm going to go from corner to corner. Now obviously on my Open Math, they graph them for you very nicely. It's a lot easier than having to construct them yourself. But it is good to see it at least done once. Okay, construct all of that. Now we open up and down. And that is what example 5 should look like.